Okay, everybody, maybe we can get started. And just as we're kind of warming up here, if you haven't filled in your responses yet to the poll questions that are here on the screen, you can feel free to do that. It looks like we've got lots of good feedback about Git so far.
Yeah, so we have 2 questions for you. How's it going with Git? And then any other questions about last week? Because we're kind of thinking that most of the confusion is related to Git. So please tell us your thoughts there, or of course you can speak up if you'd like. So indeed, it's a bit difficult to grasp. And also last lesson, maybe at the end, it got a bit confusing as people were proceeding in different steps. But maybe using Git is something that you need to do hands-on, repeat many times, and then you'll get the hang of it. There was one comment about not realizing the advantage of using it yet. That's fine. Maybe one advantage already right now is that you can easily get the exercises from GitHub to your machine or the cloud computer. So that's a clear advantage already now, and then we hope that you start liking Git more and more during this course and also adapting it into your workflow also after the course.
Yeah, I would say that in general the feedback looks pretty typical for new Git users.
Yeah.
Because at least my experience was I had absolutely no idea what Git was for, why I should use it, or anything like that. When I started using it, I was told that I should use Git and that it's important, but it took a little while to kind of figure out why it actually is useful. And actually the most useful cases for me personally with Git have been cases where I've made a mistake in something and had to go back and fix something, or I broke something that used to work in my code and I could go back a few versions ago and say, oh, okay, I see what I did. Because sometimes you are working a bit frantically and not really paying close attention to the things you're changing in your code, and you accidentally delete a line or something like that. If you can go back and see, every time you save something in Git, exactly which lines changed, it makes your life a lot easier, especially if you've accidentally knocked out 3 or 4 lines in the middle of 500 line code. It can be pretty difficult to track down that mistake sometimes. So we'll see. There's part of it is tracking the changes with Git, and you'll probably yourself get some experience with things where you make a change and save it to Git, and then you realize later that you actually had something working properly and you thought you fixed it. But also, the other part of the way that we introduce Git here is using GitHub, because there's so much software that's out there that's available to you, and if you have some familiarity with how to get things off of GitHub and how to clone a repository, it opens up a sort of world of different options of software you can use that, if you don't have any idea about using Git or GitHub, might seem kind of too confusing to get started. So that was also my experience when I first went to GitHub's website, is I saw there was a bunch of cool software there. There were things that I thought I could use, but I didn't actually understand how to get them. There was no sort of install button or something like that. And the process was just a couple extra steps that I needed to understand to be able to use the software. So hopefully you'll sort of you'll be familiar enough with GitHub when we're all done that you can feel like you can go and see some cool Python project and clone it and start messing with the code.
Yeah. So what we now introduce is the basic workflow that you'll be using when working with the exercises. So we always start by cloning the exercise from GitHub to your local machine or cloud computer. Then you have the files on there. You go and solve problem 1. You add the changes to the staging area. If you don't like your changes, you can kind of wipe them out. Then when you added them to the staging area, you queue up the changes you want to commit next. Then you commit them, you take a snapshot of that stage of the project, and then once you have committed the changes, that's one version of the project on your local machine. Then you git pull, synchronize the changes over the network to GitHub, and then you proceed. So if you follow this workflow, often you shouldn't get into trouble. There's one comment about it getting chaotic. If you get into trouble, we haven't taught and we won't be teaching a lot how to solve merge conflicts. I guess if those appear, then we'll solve those case by case And remember that you can always then download the file and upload it manually to GitHub as we did in exercise 1 if everything is like the terminal prompt is exploding. So, yeah.
So, and I think hopefully the way in which we're using Git either from the command line or from this little plugin in the Jupyter Lab system makes it pretty easy to use. You can, the sort of how often you pull and push things depends on how you're working. If you want to commit a bunch of changes, you can do that, and then can I
somebody
get up in the lesson video? Okay.
maybe same comment as last week.
Yeah. So I think the sound issue we can try to solve here quickly.
Yeah, but maybe that's enough now about Git. We could check if there's any other comments about the lesson. Not yet there. We need to switch over on that screen. But if you have any other comments, last week you learned lists and indices, right? Mm-hmm. So you'll need that information today to continue with for loops, for example. So, yeah.
And there were no comments about the
no
other
comments
question.
no other comments. So let's then maybe proceed. Maybe a few other general announcements. So all of you should have received feedback for exercise 1 in your exercise 1 personal repository on GitHub at the end of the README file. If you haven't received feedback, maybe contact me after the lesson. If you have received feedback, but you're confused about some of the comments, please contact the person who gave you the points. So it's all the assistants and me partially are then checking the exercises. And all in all, the point of exercises 1 and 2 is to get everybody along so that you understand the environments, you get a bit taste of Python. So if you weren't able to upload your exercises 1 or 2, the deadline has passed, but don't worry, we can then also check those in this week's practical sessions. So no reason to panic. Yep, that's it.
Okay. So let's have a look here at where we are for this week. You can see here in lesson, I'll refresh this because lesson 3 is not visible, but there we go. So we're here in lesson 3. Take a look at the overview for this lesson. And what we're going to focus on today are 2 pretty fundamental programming concepts that are related to a topic called control flow. That's basically just determining how different parts of a program get executed. And the 2 things we're going to focus on are loops, or what are called definite loops in this case, that allow you to repeat a certain part of a code a certain number of times, and conditional statements, which use logical tests to determine what part of a program would run. So, if some condition is met, you do this part of the program, otherwise you do some other part of the program. So we'll see that. Those will be our 2 kind of hands-on Python lessons for the lesson today. And then we've got something here about a good coding practice, about writing readable code. So Volko will walk you through a little bit of a style guide for writing your Python programs. It's not necessarily something you need to follow strictly, but there's some really useful tips in there about how to make your code easy to read as you're writing it and make it easier for you yourself and other people to just look at the code and understand what it's doing. And that's kind of an important part of writing even these relatively short programs that we're writing. And then, of course, at the end, we'll take a look at exercise number 3 about for loops and conditional statements. One thing to note, I think the CSC notebook system should be working just fine now. If you're having any problems with that, you can feel free to jump onto Binder for this part of the lesson. But we're going to start here with for loops. And so you can, if you're in Jupyter Lab, I'm just going to go here to my notebooks, lesson 3, and open up the notebook called forloops.ipynb. So I'll open that up, and then I'm going to hide this little thing. I guess that's big enough. Maybe I'll make it just a tiny bit bigger, like that. Okay, so as mentioned, these loops allow us to repeat a certain part of a program a certain number of times. And this is a very common thing that we're going to do, especially with the way the course is set up. One of the ideas we want to provide you with, and one of the kind of skills we want to provide you with, is the ability to batch process data. So to take a whole list of data files and perform some action on all of those files. The most common way to do that is to use a loop that would then read in a file, do something to it, and then proceed on to the next file and repeat the same actions over and over. So we're going to start here with a bad example, just to kind of give you some idea. So this first cell here has a list of cities in Europe, and you can just run that cell. If you're in the notebook, there's no need to type anything in there. And the way that we might normally go about checking the values in this list if we didn't see the value. So remember last week when we talked about build the vending machine, there was the sort of different items in the vending machine and then the number that you could use to refer to the location of one of those items. And the first item in the list was always at index 0. So we can print European cities and then the item from this list at position 0. And of course we get Helsinki back, as you might expect from having looked at the list here. Now, if we wanted to sort of make our lives a little bit difficult, we can copy and paste this into the next cell and then look at the value in list item number 1. So we get Paris there. List item number 2, I'm just copy paste and then running the cell, we get Barcelona, and then finally Uppsala. So those 4 cities, not a big surprise that we can go through the list and print out the items like that. We see that there's 4 items in the list. But this isn't really a very good way to do this, because you can imagine as the size of this list grows, you're going to have a lot of copying and pasting, and every time you copy and paste and change something, you've got a chance you'll make a mistake in doing it. So you may be dealing with syntax errors, assuming you don't want to just print the name of something in the list, but you want to do something else with it. You may cause yourself a lot of trouble by copying and pasting every single time. But this would be a pretty typical way for someone to do something without the idea of a loop in their skill set. And it's also problematic because as the list gets longer, it's going to take forever to do this. So if we had 1 million cities in this list, even if you copied and pasted them perfectly, it's going to take you a long time to print all the values out. So let's take another look here at a different list of European cities, and we'll see another problem with the approach that we have here in terms of what we've hard-coded in. So if we run, again, this cell here, we're going to have 3 different cities, and we can do basically what we did before. We'll just copy and paste in this print statement, European cities, and we'll start with the first one at index 0. And of course we get Riga back here, go and edit our cell and run the next one. We get Rome, and then finally here we get Athens. And the thing is, if we kept our code from before, we would also then be printing out this print statement for the item at index number 3, which of course is out of the range of the values in this list. We have 3 values at index 0, 1, and 2, and if we try to look what the value is at index 3, we get this index error that says the index is out of the range. So we're trying to access something that's not in the length of the list we have here. So again, this is a problem that if you just copied and pasted this code trying to process a list of cities with a different number of entries, you're going to again face trouble, even if you copy and paste everything and edit it without an issue, which is not likely as the length of the lists grow. So the whole point here is that we can do better in Python, and any of you who have dealt with other programming languages before already know that the concept of a loop is something that can save you quite a bit of work. But we have to know how to use it. So that's what we'll do here. If we take, once again, another list of cities, I've already provided that for you, so you can just run the cell. We'll populate a list now with 4 other cities. And let's go through the same exercise of printing out the names of the cities, but we'll do it this time with a for loop. And to do this, we can type for. And then we're going to type in a name of some variable here, which we're going to call city. And we'll say for city in European cities. And then put this colon character at the end. So we start with the for statement. Then we have some variable name here. This variable is, you're free to kind of name this whatever you like. It's something that's going to be assigned as we go through the list of cities that we have here. So this, then, European cities should be some list or some other kind of collection. It could be, you know, an array or something like that, depending on what kind of data structure you have. And then it's always going to end with this colon character. If you press enter, you're going to see that the Jupyter Notebook will automatically indent the line underneath this for loop. So this is something we haven't seen yet. And this is something that turns out to be kind of a fundamental piece of how these for loops work. But first, let's take a look here and add our print statement. And what we're going to print this time is city. What's going to happen here is that as we go through this list of cities, we're going to start with the first one, and its value is going to be assigned to the variable called city, and then we're going to have a print statement. Of course, that comes up, where we print out the value for that variable. The for loop is then going to go to the next value in the list, and it basically just keeps going back as long as there's values in the list, finding what the value is, assigning it to the variable city, then it gets printed to the screen. So if we run this cell, you'll see here that we get our 4 cities printed out on separate lines, as we would expect. This is basically the same kind of thing we did before, but now with this for loop, we're basically saying go through the list and perform this operation for each value that you encounter. The way in Python that you indicate that you're done with doing things like operations you want to have happen within this set of steps that happens for each city is that you then go from having an indented line back to having text where there's no indent. So if we added a print statement down here that says done, what we should see now is that we won't get done printed to the screen 4 times. We'll only get our 4 cities, and then after we're done processing the list of cities, we'll get the word done printed to the screen. And if you run the cell again, that is what you should see. Now, just for the sake of demonstration, if we were to indent this line underneath here, it would be considered part of the set of steps that happens when the for loop runs. So we should now see the name of a city and then done. Then the name of the next city in the list and then done. And if you run this, that's exactly what you see. So the trick here to indicate what you want to include in the for loop and what you want to include in terms of the code that should run for each value in the list is that it's indented. Then when you're done with that stuff, you say, okay, I'm done with the for loop. And if you then shift it back over to the left side, you should see what we saw originally, which was the 4 cities and then the word done. Okay, so this is pretty handy. And if we take another list of cities here, you can see another reason why the for loops are pretty useful. So we'll try another one. We'll start again with the word for. We'll also use the variable name city because this is also a list of cities. But we'll say for city in US cities because why not have a different list of cities? Before we do that, it's probably a good thing to define this list of cities. So let's say that this is equal to, and I'm just going to copy paste this stuff from up here because I don't want to type whatever number of cities this is in. So we'll copy the text from the cell above, paste it in here. So now we've got a variable US cities. That'll be this list of cities. And then we're going to say in our for loop, we'll do the same thing. Actually, let's make it a little bit more interesting. So we can say city and then is a nice place. So, we can add a little bit more text here. Same thing's going to happen. We're going to go through each one of the cities, and we'll process them by printing out the name of the city, followed by is a nice place. And if you run this, then just as expected, you see Detroit is a nice place, Chicago's a nice place, Denver is a nice place, blah, blah, blah. So this is nice from the standpoint that if we want to give this list of cities as 10 million cities long, our for loop can handle that, no problem. It's 2 lines of code, and it can process as many cities as we want up until, if you get really extreme, I guess you could run out of memory on the computer with, several billion cities. But the point here is that we can basically have this flexible structure that will work with whatever number of values we have in the list and print them out to the screen. So I guess, is that sort of making sense? Yeah. I guess those of you who have seen other programming languages, maybe you don't have exactly the same syntax, but this loop structure for definite loops is kind of everywhere. So if we just take a look at the format once again, the idea here is that we have the for statement, then the name of some variable. Just to demonstrate, if we go back up above, we don't have to call this city. We could call it place. And all we have to do then is say that, okay, well, we're going to print out the value here in our for loop. We should also then print out the variable called place. So this is what's going to be assigned to each one of the items in the list as this part of the code runs. And if you run the cell again, making those 2 changes, you get exactly the same output you saw before. That's no big surprise. So the general format we have is for variable in some collection. Again, the collection could be a list or some other thing. And then we're going to do some things with that variable. So that format, I think, is relatively clear. The key things here is that you start with for, that you've got a variable, you've got the keyword in, and then some list or collection followed by this colon character. If you're missing the colon character, you'll get some kind of indication that you've made a mistake. If we just go up above and delete this, we get a syntax error. And Python's even nice enough to tell us, like, hey, something's missing here. So you can see that little kind of character saying, like, hey, you got to put your colon at the end of this. And if we do that, then everything is okay. So that's the sort of structure. Typical indentation would be 4 spaces in Python. It's not advised to use the tab to do your indenting, and that will perhaps come up in the PEP thing about writing nice looking code that Vocal will cover later in the lesson. But typically it's 4 spaces. You can use fewer. You could use 2 or 3 if you like, as long as you're consistent. So when you do the indentation, you should be indenting by the same number of spaces every time you've got something within a loop. So if you did, 2 spaces, then 5, you're going to get an indentation error. So yeah, just to kind of make the point here about why this might already be something familiar to you, we've got a little sort of cat cartoon here that you can read through at your leisure. But essentially, you could think about a for loop as sort of similar to your daily, your kind of daily agenda. The things that you do every day. You wake up, you might eat breakfast, take a shower, whatever. You sort of go through the same set of steps most days. And you've got different courses you might come to and different things like that, but you pretty much have some certain set of steps that you repeat pretty much every day. You wake up and you do certain things. I went for this kind of cat cartoon in part because it's sort of silly, but also that when I was looking for these daily routines, almost all of them had children sitting on a toilet. And so it was like child's daily routine, and I kind of felt like that wasn't really appropriate for our course. So anyway, so we've got a cat instead kind of acting crazy. But you could think about it this way. For a day in your life, you wake up, take a shower, eat breakfast, brush teeth, blah, blah, blah. Come to Kumpula, love your class, celebrate being a student, whatever. any number of these different things you want to put in here, you repeat many of them every day. You could make this list be like the weekdays where you do certain things, and then the weekend you might do different things. But this is the sort of concept, is you're repeating certain actions day in and day out. So just like you can think about Bill when we talk about lists and indices, maybe you can think about like the loop of what you do during the day, and your sort of daily routine for the concept of a for loop. All right, so let's cover a couple more things here about these for loops. I guess maybe I'll pause here for just a second to see, are there any questions at this point about the for loops? We're going to have a chance for you guys to play around with thinking about for loops in just a minute. But yeah, I don't see anyone who looks like they're dying to ask a question. So, all right, so we've got our for loop here. Now we've got a new one for weather conditions. And what we want to do here is, again, something that's maybe not the most exciting exercise, but we'll run the cell up here first for the weather conditions. And then we'll print them out with a for loop again. So we always start with the for statement. And let's call this weather, in weather conditions. So we're just going to use the name weather as our loop variable this time. Again, our list now is called weather conditions, and we end the for with a colon character. And then we can print out what the value of weather would be in this case. And if you run this, again, what you see are the values of the list printed to the screen. Not very interesting. But the important thing here is that this variable, weather, is just a normal variable. So once it's been defined in this for loop here, we can do things like print out what the value of weather is after the loop has been run. And you see it keeps the last value from the list in memory. I point this out in part because it's good to know that this is just a regular variable. It's not something special. It's not like in a reserved namespace or something. It's just a regular variable. But also that you have to be a little bit careful sometimes if you choose certain names for your variables in your for loops. If you use that same variable name later on in your Jupyter notebook, sometimes it can still have the value that was associated from earlier when you ran your for loop, and it could cause trouble that, if you defined it to be some number and then you use that variable in an equation later without changing its value, then it would take whatever the last number was from the list of numbers you had in a for loop. So, if later on in our notebook we use the variable weather without redefining it, it's still going to have the value ice pellets, and if that's not what we wanted, that could be trouble. So what we've seen so far are these loops where we take a variable and we loop directly over the values in a list, like weather conditions. So we've gone through and used these values directly out of the list. There are some other options for how we can use for loops, and one of them that we'll talk about now involves using a function we haven't seen called range. Just to see how it works, we'll do a simple for loop here and print out the values of the range function. It's pretty useful, and let's take a look at how it works with a simple example. So we can start here with for, and we'll just call our variable this time value in. And now, instead of giving a list, we're going to give the function range, because range doesn't exactly produce a list, but it produces a collection of numbers. So if we put in for value in range 5, this is going to do something. We'll see what it does in just a moment here. And then we print out what value is. This is essentially like what we've done with the other for loops. We have here our variable. We're going to print out what it is, and range 5 is going to be some collection. If you run this cell, what you see is you get the numbers 0, 1, 2, 3, and 4. So what the range function does is it produces a list of numbers, of typically whole integer values, and at least in the way that we've set it up here, that's how it works. And what it will do is it will produce a list of 5 numbers by default starting at 0. So instead of you don't see the number 5 here, but you see 0, 1, 2, 3, 4. So those are our five numbers. And it can be a little bit confusing because sometimes if you think, okay, I want to use range to give me, the number 5 in my list, you have to do that a little bit differently. And this is one of the things that can be a bit annoying with Python. The range function is meant to provide you 5 numbers, doesn't necessarily include the number 5 in that list. If you want 5 in there, then you have to do the sort of somewhat unintuitive range 6 to get 5 included. But again, that's because range function is going to give you this many values, not numbers up to the number 6, for instance. We'll see how that works in just a moment. If you want to know more about the range function and what you can do with it, you can definitely do more than just like getting single numbers. So we could say like, well, actually, we'll save this for what you can look at. But there's a help option in Python and in these Jupyter notebooks that if you type in help and then with the help function range and run this cell, this gives you documentation on the range function. We'll come back to this a little bit when we talk about functions ourselves and writing our own functions, but basically this will allow you to get some documentation here, so you can see that like how if you want to define the range function, you can put in like a starting number and a number where you want to stop and a step. So this would be like, if you want to start at 4 and then stop at 12 and then put a step of 3, you can do things like that. And you can read through here if you like. In fact, you're going to probably want to do that because our next stop is a little poll question for you about using the range function. So what we want you to do here is to consider a for loop that uses this function range and just prints out the value I. So our loop variable here is just called I. And what we want you to do is tell us what values you would put inside this range function in order to get it to print out 2, 5, 8 to the screen when you run the function. So for this, you're probably going to want to look up above at the help and the description of how the range function works. And then once you've had a look at that, you can think, okay, if I was to do a for loop with a range, what numbers would I put into the function here in order to get 2, 5, 8 displayed on the screen? So that's the question for you, and we'll have the poll responses up on the screen here in just a moment. Maybe what I'll do is put them over here, just because we can't see the question otherwise, I don't think. Unfortunately, there's no way to put nice Python code into our little polling system. So you can see the responses there. Think about it for a moment. What would you put into the range function? And once we have a few more responses. Yeah, once we have a few more responses and I've got my microphone back put together, we can continue. So we've got 44 online, around 20 responses. Maybe we can get a few more responses here. You know, you've got time if you want. You could even test this out, but we want you mostly to think about it, not to copy paste the options in here. And you know, just it's a good thing to consider here. All right, so 25 responses was the number I had in my head for where we would continue. So we're there now. Okay, so what do we have? Well, let me just switch over so that I can put this on this screen and we can both see the same screen there. Okay, so we've got the options. The ones that seem to clearly be the two that are leading the way are either that we have 2, 8, 3, or 2, 9, 3. So indeed, the first number here would be the number that the range function is going to start with based on the documentation. So we would expect to see that this has to be 2 for the first value, and that knocks out these two options here that start with 0 right away. But the question is for the middle value there, that is the value that is listed as the stopping value. And that goes back to that kind of funny behavior of the range function that you might expect this to be the number 8 if you want to have it stop. The step, of course, between the values is 3 here. But you might expect for it to be 8 if you want to have it stop with 2, 5, 8, but in fact what that would do is it would go up to but not include the number 8, which is the sort of counterintuitive and sometimes frustrating thing. So if we add a code cell here, I'm just going to put one down below and say for range in, or I'm doing this completely wrong, for I in range. And so we had 2, 8, 3. And we print out what I is. We only see 2, 5. And the reason for that is that we see first 2 as our starting value, then we increase 2 by 3. That's the step. So then we get 5. And then you would increase 2 by, or sort of increase 5 by 3 once again, but the way the range function works is it goes up to but does not include the value 8. So if you want to get 2, 5, 8 to the screen, this middle number here has to be a 9. This will be something that you will encounter trouble with in the future. I'm quite confident about that because basically it happens every year. It happens to those of us who are experienced programmers that sometimes you just forget that the range function doesn't include the last value in what you're trying to do, and then you can't figure out why you're getting one less value printed to the screen or one less value in the list you're generating or whatever. Any questions about this example? Yes.
I don't know if you showed, but just where should have we gotten the information about the parameter?
Yeah. So the question was basically a reminder that we should look here at the documentation just to see how this function works. Everything that we're talking about here is described. Typically, if you use the range function with just a single number, you only give the stopping value. So it's going to just take steps of 1 from 0 up to, but not including, stop. So that's why when we do range 5, we get 0, 1, 2, 3, 4. Here, the same basic idea applies, but in the range function, when you give a value for the starting number, it's going to start there at exactly that value. Similarly, we'll go up to, but not include stop, and then the step in there would be the number of values in between. You can see here in the description that this range function returns an object that produces a sequence of integers from start, and then it says inclusive, meaning that that value for start is included in the list, to stop, exclusive. So it's not included in the list by step. And then step would be whatever the number of values is in between. So it even goes further and says with an exclamation mark, stop is omitted. So just to make it extra clear that that's how the range function works. This documentation you can use and look up other things, like if you look for help for, well, you can't do that because it's not a function. But if you did help print, you could then see the documentation for the print function, and it allows you to see interesting things like this, like by default, the print function includes this character for a new line at the end. If you wanted to do something cool and like make a print statement that didn't include the new line, you could do something like print, check this out, mom, and then if you wanted to have it all show up on one line, you could do sep equals, and then just a double quotation mark. So what we're going to, or sorry, end, not sep, end equals double quotation marks. So we're going to say at the end of the print statement, instead of putting this new line special thing here at the end, let's not do that. Let's just leave nothing at the end of the line. We could then print underneath it, 2 prints on one line. And if we run this, we're going to check this out, mom, space, and then 2 prints on one line. And because we set the end character to be nothing instead of the new line character, it prints them both on a single line. That's the kind of thing you can discover if you look up the documentation for some of these functions. There's a lot of neat things you can do that we're not going to have time to cover in the class, and if you use the help, you can dig in and find some interesting stuff. This was a totally unplanned example, but it's just an example of what you can find if you dig around. So any other questions about this range function? We got a couple other things to cover here about range, and then we're going to figure out what to do next. So, okay. So what our next step is to take another example of using a loop, but this time we're going to loop using the index values, because with the range function we can use the values of the index of the items in a list to be able to do things with them. So we've got our list here called numbers. It's just 0, 1, 2, 3. And you can run that cell just by itself. And we're going to use a new format here with our for loop. So we'll call this for I in range of length of numbers. So we already had this len function we saw before with lists that tells us how many items are in the list. The range function will allow us to go through and do something a certain number of times. So numbers has 4 numbers in it. Length of numbers will be 4, and range of 4 will allow us to repeat this loop 4 times. What I want to show you with this example is a little bit of what the output looks like for these different values in this for loop as we run it. So first off, we can print what the value of I is. So we could, maybe I'm going to do one thing before we do this, and that is I'm just going to change this list of numbers a little bit so it doesn't start with 0. Let's have numbers start with like 5, 6, 7, and 8. Just make a small change there. So you can run this cell again. We got now 5, 6, 7, 8 in here for our numbers. I just want to avoid a little bit of confusion that could come up here. So we're going to print out here what the value of I is. And then we can also print out the value, we use the list location at index I. And I is going to be coming out of our range function from earlier. So then this would be numbers of I. And then we're going to take our value for numbers of I and change it. So we're going to say that numbers of I equals numbers at location I plus I don't know, plus I. Doesn't matter. It could be plus some other number, but we'll just add I to it because that's a useful thing to do. And then we'll print one more time. So this is a little bit of typing practice for you, but we'll take a look now at the value of numbers of I after addition. And again, we'll just put here numbers of I. So I'll talk about this for a second just before we run it. And finally, I'm just going to add a print statement with 2 quotation marks just to give an extra blank line at the end. I could, since I know how the print function works, I could add an extra new line in this last print statement here, but I don't need to go crazy. So what we have here is a loop, for loop that's going to have 4 print statements. The first one's going to print out what the value of I is each time we go through the loop. The next one's going to print out the value of numbers at index I each time we go through. Then we're going to modify that value and then print it out again. And finally, we're just going to print an extra blank line just to separate out each time we pass through the loop so we can read this a little bit more easily. So if you've managed to type all that in and you run this, here's what we see. So for instance, the first time through, we see the value of I is 0. So this is coming from the range function. It's not a big surprise if range 4 should give us 0, 1, 2, 3. So the first time through, I is equal to the first value in the range, so 0. Value of numbers of I is 5. That's because it's index 0 in our list, so it's the first number. And then number of I after addition is still 5 because we added 0. So that's not a big surprise. If we look at the next one, value of I is now 1. So second pass through the loop, we take the next value from the range function. So now its value is 1. Now we're going to go through using the value I equals 1. So there's I equals 1. Now we look in the list of numbers at index 1 and we see this is 6. So second number in the list as we expect. And the value of numbers of I after addition is now 7. And that's because we've taken the value that was at numbers of I previously, 6, and then added the value of I, 1, and we get 7 from that. The point here is that this addition, so the stuff over here on the right side happens first. So when you modify the values of numbers of I, anything on the right side will happen first. So you can definitely refer to the old value at this location in the index, modify it, and then store it back in the same location in the list of numbers. So we've modified our list of numbers at this point so that the second value instead of 6 is now 7. Same thing happens the next 2 times we go through. So now the value of I is 2 the third time through our loop, and then the value of I is 3 the fourth time through. And each time we then go to index value 3 in our list. In this case it would be 8, and then we add 8 plus 3 to get 11. This might seem a little bit, I don't know, it could possibly be confusing, but it might also be seeming like kind of obvious. But this loop structure using this range of length thing is pretty common thing to do. And keeping separate in your head the index value I from the values in the list is something that often causes a little bit of confusion in the course. So in the end here, if we print out what numbers is, we've modified it. And as we can see now, instead of having 5, 6, 7, 8, we now have 5, 7, 9, 11. Because in each case, we've added the value I. So 6 has gone up to 7, 9 has come from being 7 before, and then 8 has gone up to 11. Does that make sense? Do you guys kind of follow what's going on with that example? You'll get practice with this, so it's not the kind of critical thing that you are rock solid on it right now, but it's a good example just to kind of see the difference between the index values and the values in the list and how you can modify them. What I've just described is basically summarized in the text here on the lesson, so you can see that if you want to read through it as well. Essentially everything that we just talked about is described here. And there's also a note that the value I is very commonly used for the index when you have a for loop. It's probably the most common choice. If you've got multiple for loops, you can have them sort of nested inside of each other. we'll see this in the exercise this week. And then you might use like the letter J for the loop inside of another loop. But anyway, that's there. So why bother with this? Maybe you're wondering, like, it seems way easier just to loop over the values in the list directly. Why would I ever want to use this length range combination to do something? So we'll see an example of that here. So now we've got some cities and we've got some countries. You can run those two cells just to put those lists in memory. And we can print out some information about both of those things together at the same time with this range of length thing. So if we say now for I in range of len cities, so we've got 5 cities. Len cities should give us a value of 5. So then for I in range 5, basically, we can have a print statement that says city or cities of I is the capital of, and then countries of I. So what we're taking advantage of here is that we have a list of cities and a list of countries where each city has a corresponding country in the other list. Both lists are the same size. So you see, for instance, for Helsinki, that Finland is listed here. For the country, for Stockholm, Sweden is listed. They've all got pairs. And if we want to print them out together at the same time, we can't loop over the values of cities themselves, at least not without doing something kind of clumsy. So the easier way to do it here is to use this range function. And if we run this cell, then we can see Helsinki's the capital of Finland, Stockholm's the capital of Sweden, blah, blah, blah. In this example, each time we're taking advantage of the fact that the index value in the list can be used to refer to the city or to the country because they're in the same place in each one of the lists. So this is just one example of how you might want to do this. There are other cases where we'll see these in the exercises, especially those who continue on to the quantitative geology course will see this kind of structure where we want to use values at 2 locations that are sort of same location in 2 different lists, and do some calculations with that. So hopefully that example is somewhat clear. I think it's, we're getting a little long into the for loop lesson at this point, so if you're not totally following everything at this point, again, you can always go back and look at the course page where this example is also shown there, along with a little bit of text explaining it. The one thing I want to point out here is that it doesn't matter whether we use cities or countries here in our length function. The length of countries and length of cities is the same. So if you put in countries there and run this, it gives you exactly the same output that you had before. Yeah?
So would that have been a neater way of doing problem 2 for homework?
Would that have been a neater way for doing problem 2? Yeah, I think so. I'm trying to remember exactly what problem 2 was. This is where you had like, yeah, the temperatures and stations. Yeah, exactly, right? Because you have corresponding things in the same list. You could do it with a for loop, but we don't know about for loops in lesson 2. So, but yeah, exactly. That's the kind of thing that makes this useful. The idea in that lesson was mostly just to recognize that you can use the index to refer to the same location in 2 lists. But then if you take that and put it in a for loop here, then that's exactly right. This would be a much better way to write a flexible code. Like, let's say you wanted to print out all the cities or all the sort of stations and temperatures, or you wanted to print out month and temperature, whatever it is. You could do it with 2 lines here rather than having 12 print statements if you had every month and its corresponding average temperature, for example. Yep. Okay, so we have one more poll question here. I think it should be set to go. So just to test the concept here, what output would you get for the following little program here? So we've got a list of odd numbers and a list of even numbers. You'll notice that they are of the same length. And then we have basically the same structure here for I in range, length, odd numbers. Print odd numbers of I plus even numbers of I. And so the question for you to consider is, what output would you see printed out to the screen? And your options are here on the polling page for this question. So please jump over there, take a look. I will pop up this live results screen, or whatever you want to call that, so we can see what we have. So it would seem either that everybody's following the early leading result here, or maybe you guys got ahead because there's already 37 responses here, but that's good. So what we have basically is the right response here. We would expect to see that when we run this, the commas would separate things onto different lines, but we should get 11, comma, or 11, 7, 11, 15, 11. The reason for that, if we jump back to the example we were looking at here, is that what we should see is that when we go to the first value, when I is equal to 0, odd numbers at index 0 is 1, even numbers at index 0 is 10, and you would get 11 there. Then you would get 3 plus 4, 7, and then 11, 15, 11 in this case. There would be nothing like a syntax error or an indentation error, because you can see clearly this is indented. It happens to be 4 spaces. It could be less. I've got all the sort of necessary pieces here for some variable in some list, colon. Everything looks okay, so we shouldn't see any issues with like syntax errors or indentation errors. And yeah, we're not printing out the values of I, we're printing out the sum of the list values for odd numbers and even numbers lists. So yeah, looks like everybody is on board with that part of things. I think at this point, it's probably wise to take a short break. So why don't we do that? And we will continue with conditional statements in 15 minutes or so. Yep, at past.
Are we live? Okay. Okay, so let's continue the third lesson slowly. Here, so Dave introduced you to for loops, and you'll use those excessively in this week's exercise. We have the other main topic, conditional statements left, so I'll walk you through that section. And just a reminder, if you have any questions already during the lesson, please stop me or then go to Slack, ask there, ask a friend. So if you get left behind, so do interrupt us. All right, so conditional statements looks something like this on the web pages. You can follow either on Student Binder. We recommend you use the CSE notebooks, and we can then start going through the lesson over there. And I have my version already open. Is the Zoom level fine and stuff? All right, so let's go. Conditional statements. So that's kind of another, together with for loops, an essential part of kind of controlling the flow of our code. So conditional statements are all about making decisions. If we get some kind of value, what should we do then? And if it wasn't as we expected, we could do something else. So if something, then what else? Something else. These sorts of decisions. So yeah. And we'll start by just looking at an example, so you don't have to yet type in anything. You can of course run the cell if you want. So we have a little if statement to begin with. So first we assign value 7 to the variable temperature, and we would want to check if that temperature is hot or not. Here we're of course assuming that these are Celsius degrees, and for us Finns, maybe like something greater than 25 degrees begins to be quite hot temperatures in the summer. So just reading this out loud in English. So if the temperature is above 25 degrees, if it's greater than 25 degrees, then we could tell that it is hot. And then in all other cases, so if it is less than 25, we could tell that it is not hot. So we write this by using the keyword if. Then we have a condition, so a conditional expression that is true or false. Then similarly with the for loop syntax, so we end kind of the if statement with this colon. And then in an indented code block, so again we have this 1, 2, 3, 4 spaces there. We have a statement that gets executed if the condition in here is true. And then we have another keyword else here. So if the condition is not true, then we would print it is not hot. So now we can start modifying this a bit if you like. So for example, if we would then put 30 degrees dreaming about the summer, so then the code would go from here. It assigns value 30 to variable temperature. Then it checks if temperature is greater than 25, then print it is hot. And if this is true, then it will ignore all the following else statements or elif statements, and then we see on the screen that it is hot. I'll just return it to the original position. So in this case, we defined or assigned value temperature to be 17. The code comes here if temperature is greater than 25. Is it? It is not. So it skips the following code block, and then it executes whatever is written here after else. So that's the kind of very basic example of a for loop. And of course, this kind of logic we use in our everyday lives. So if it's raining, maybe wear a raincoat, or if it's a weekend, don't go to the university, hopefully. So if something is true, then do this, or if it is not true, so if it's false, maybe do another thing or don't act at all. So we could have a look at another example with a string variable. So talking about the weather, so we can assign variable weather to have the value rain. So that's a character string. And then we check if weather equals rain, we should wear a raincoat. And if it's not raining, then we don't need a raincoat. And here there's a bit different syntax compared to the previous example with the integer value. So here we are comparing if weather is equal to rain. So this kind of double equal sign. And the difference between this assignment single equal sign is that we're here not defining the value of whether we are comparing two things here. So is weather equal to rain? And if we run this, we see that the code, first it takes the value of weather, then it checks if the value of that variable equals to rain, then print this statement. And if it wouldn't have been equal to rain, then it would print that we don't need a raincoat. So again, if I would modify this, weather is sunny, then no raincoat is needed. So we control the flow of the code, which lines get executed and which lines don't get executed by this if and else statements. And indeed, the syntax is similar to the for loops. If you have written if statements, for example, in R or Java, you might be used to having these kind of curly brackets which say that where does the if kind of code block start and end. But same thing as with for loops. So the indentation tells us what part of the code kind of is conditional to the if statement in there. And also there is the colon that indicates where the if statement ends. So if you would like to test this a bit, so you can, for example, copy paste this block of code from there. Let's see. And run it. So in this example here, we again have a rainy weather, and if weather equals to rain, then the code will print several lines of code, and in other cases it would print no rainwear needed. If I would then, for example, have an indentation mistake on that line and run the code, you'll see again that Python tells us that there's an indentation error. It's kind of confused because it doesn't find an indented code block after the if statement. And again, you can try if you want, you can modify this. So for example, then it's snowy. So you don't need rainwear, but you might then need to modify the conditions, add conditions to catch other cases. So often we start with a simple condition, something is true or not, but then when we make a more complicated code, you start noticing that you're not catching all the possible cases. So for example, for snowy weather, we could add then another condition to tell that you might need, for example, a winter coat. in that case. Okay, so we'll discuss a bit about this conditional expression now. So you saw two different examples of comparison operator there. We had this greater than and equal to, and we have a set of other options as well to compare two values. So we can check if one value is less than or equal to, greater than to or equal to, greater than or not equal to one another. And you can also have multiple conditions in the same conditional expression if you like. And the key point here is that one kind of conditional expression is always true or false. So if something is true, 17 is, well, let's say 30 degrees Celsius is greater than 25 degrees Celsius, right? So if it's true, it is not false, but if it's false, it is not true. So it's a binary value. You have only two options. It's true or false. If it's true, it's not false. So you can either type it in or then copy paste from here. So let's check a bit what kind of conditional expressions we had. So first we had this temperature is greater than 25, and currently I have some value of temperature in memory, and I can just run that. Currently my temperature is 17, and if I run this temperature is greater than 25, so that block of text equals false. It's a false statement, so if false, then the if statement code block doesn't get executed, right? And then the other example was that weather is equal to, whoops, rain, okay, sorry, I hope I didn't break anything, rain. So at the moment, I think our weather equals to snowy. So at this point, weather equals to rain is false. If I would update the variable weather, so I assign weather to rain, and then I check if weather equals rain, then I'll get true. And furthermore, I could still check the data type. So you remember from week 1 how to check data types. So the data type of what this expression returns is bool, which stands for a Boolean value. So coming back to these examples, what happens kind of in the background, you have if true, then execute this. If false, ignore this line. So it's either or, true or false. Yeah, so that kind of makes sense. I'm sure you have all come across these kind of logical expressions, true or false, greater than, equal to, at some point of your school life. But here we'll then start using these to control the flow of our code. Okay, so let's go a bit further. So here we had, in these examples, we had always had if something, do this. If that wasn't true, do something else. But we can also have just the if statement as a standalone check. So you can try this out yourself. I highly recommend copy pasting, as we are starting to type quite a lot. So if we assign value 17 to temperature and write an if statement where we check if temperature is greater than 25, print temperature is greater than 25, nothing gets printed on the screen. Because Python first, it reads this into the memory, well, if I run it, and then it goes to check if this conditional expression equals to true, execute this line. But now, with value 17 stored in the variable temperature, this conditional expression is false. So then, according to the if statement logic, this line of code gets ignored. And then Python will go here. I could add a line print, oops, and then continuing, so kind of without indentations. And then if I would change the value of temperature back to 30, so it should be greater than 30, and then run this line again. So then if the statement is true, then we print the line and then we continue. So depending on the input value, the line is executed or is not executed, right? So I believe this is pretty logical in a way. But then of course, most often we want to have multiple conditions. So we might want to classify, for example, temperature values, or you might want to classify whatever. We could classify cities according to in which country they are in, or all sorts of different conditional situations. For example, when classifying variables. So now let's type in a few lines of code. There. So always when writing conditional statements, we start with the if clause, but then if you would want to check that if the temperature is above freezing, exactly freezing, or below freezing, then we already have kind of three optional scenarios in a way. So we need at least then two different checks. We need to check if it's above freezing, if it's exactly freezing, or then everything else, so below freezing. So those are kind of logically, they rule out each other, these cases. So let's write conditions for those. So we start with temperature 3, and then we could check that if temperature again is greater than, in this case, 0. So if it's above freezing, colon, the Jupyter Notebook should give you the indentation automatically. Then we want to print an informative message. So for example, above freezing. At this point, as we start writing multiple lines of code, it's not a bad idea to run the cell after you have kind of written the first statement. So let's just try that this works. So we run the cell, and as we learned before, we get no output because temperature -3 is below 0. This conditional expression equals to false, and then nothing gets done. Then we wanted to check if it's exactly at freezing point. So in this case, we'll use a keyword elif. We'll discuss this a bit once we have our example set up. So elif temperature is exactly, so equals to, again we use this comparison operator, equals to double equal sign, equals to 0, colon, print is at freezing point, for example. Then, when you are at this stage, you can again shift enter, run that cell. Still we didn't catch that. We don't get any output because our temperature is -3. This is false. This is also false, so none of these print statements gets executed. Then finally, else. So else works in such a way that if none of the above conditions were true, then do else. We could of course have like if temperature is less than 0, but as we have already checked all the other possible cases, we don't need to do that necessarily. It's not wrong to do that, but we can just write else, print is below freezing. Okay, and now if we run this, we get some output. So logically, the code checks if was false, elif, so else if this is also false, it's not equal to 0, so then in all other cases, such is the case in here, that it's less than 0, we print is below freezing. We could first of all also make this print statement a bit more flexible, so we can add the value of the temperature or the value of the value that we are testing in the print statement. So you can add inside the print statement the variable temperature in all of these print statements. So if we would be checking some other value, we'd get a nice output. Running it again, so -3 is below freezing, right? Everybody with me? Yeah. One more point about this elif. So you could do this. You could just have if condition, do this. If condition, do that. Else. But in that case, and you would get the same output, but in this case, Python actually will check this one, and then it will also check this one. And then if this is not true, then this else will happen. Sometimes you might want to do this, but in this case, as our conditions are kind of related to each other, we want to have the elif, so it's only if the previous if statement wasn't true, then we check this one. So if we would have value 3 in here, temperature 3 is above freezing, then Python checks if this is true, print this one and ignore all the following elif and else statements. So that kind of makes our code faster and then also more logical. So you want to avoid running lines that you don't eventually need. And also if you would have some other type of condition that you would also want to check, then you don't want to use this elif because it will get ignored if this test is true. Yeah. Is there any questions at this stage? Everything is crystal clear? Yeah? Okay, so let's continue from here. So just to reiterate that elif is kind of an additional condition that always comes after the if statement, and then else catches everything. So if all the other conditions have been false, then do whatever is in the code block related to else. Okay. Yep. So let's take a little pause to wake you up. So maybe I recommend read it first and think about it yourself before checking what everybody else answered, because that might kind of prime you into choosing the option that everybody else clicked. So we have a setting where we have 3 variables: yesterday, today, and tomorrow. Yesterday equals 14, today is 10, and tomorrow is 13. And then we have a set of conditions. So if yesterday is less or equal to today, then print A. Elif if today is not equal to tomorrow, print B. Elif yesterday is greater than tomorrow, print C. Elif today equals to today, print D. And the question is that which of the letters A, B, C, D would be printed to the screen if you would run this script. So the poll should be up there. Think about it before checking. Maybe 30 seconds and I'll put the options out there.
This tab should be just the questions.
Yeah, so you have some options also combining the different letters, or then some other combination might also be possible. Okay, let's see. So we have a little bit of variation. And of course, now that you see the leading option, that might be going a bit forward, but if, 45 online, 32, 34, almost everybody has answered. Okay, so if I am not totally mistaken, I think again the leading option is the winning one. So we could talk it through, so or even run and test it. So the conditional statements start by checking if yesterday is less or equal to today. Yesterday is 14, today is 10, so we skip A. Then Elif, if today is equal to tomorrow. How was that? Sorry. Yeah. Where is it? No. There we go. Let's see. Oh, if I remember wrong. Today. Yeah, so if today is not equal to tomorrow, then print B. Today is 10, tomorrow is 13, 2 different numbers. That's a true statement. So B will get printed, and as we have if, elif, the process stops there, and then the rest of the conditions are ignored. So of course there are some other conditions that are true. Today equals to today, that's true, but these will get ignored once Python finds the elif statement that is true. And if you don't believe us, then you can, of course, run it. So we'll get B printed on the screen. And this is a good reminder. So always, of course, think logically. What do you want to test in the exercises? You'll need to classify some temperatures and coordinate numbers. So think about it, that it's logical, and of course also run and test with some test cases that you actually end up then with the correct outputs with the specific input values. Okay, any questions about if and elif statements?
Do you want to show what would happen if you did, instead of the elif, just if statements for all?
Yeah, sure. So as we discussed, if it would be if statement, how do you delete things? Everything would be checked, and accordingly the print statements would come out. So then we would get B, C, D, actually, because there's then three conditions that are true but don't get checked if we have elif statements. So that's that. Then that kind of covers most of conditional statements. So this is kind of not a super big package. A few more notions. So we can also combine, we have this Boolean condition, so we always get true or false, like is greater than or is equal to. That's a true or false statement. But we can also combine two Boolean values or two expressions which give Boolean values with and or keywords. So again, there's two examples that you don't have to type in. We can just run them and discuss. Let's see if these were actually logical, what they print out. I had some doubts about that, but let's fix them if there's something wrong. So the keyword and takes two Boolean values, and if both of the Boolean values are true, then the whole condition equals to true. Let me know if there's some logical error in the print statements. Yeah, so in here we have first expression is 1 is greater than 0. That's true. So we have one true statement on that side, and -1 is greater than 0. That's false. So we have a true and a false statement in there. And that's why, at least one part is, yeah. So indeed, logically, this equals to false, and we end up in here. In the second example, we have the or keyword. So we have 1 is smaller than 0, which is false, or then -1 is smaller than 0, which is true. So then or does so that if one or at least one of them is true, so in this case this one is true, that's enough, so then it passes. So indeed, in the AND keyword, you need to have true on both sides of the keyword to have the whole condition equal to true. Yeah, but indeed, let's test this a bit. Dave has written us some guidance. Do you want to explain it?
Yeah, sorry, I can. I didn't know. Is that on? I can probably speak loudly. Okay, there. Now it seems like it's working. I mean, sorry, I didn't mean to distract from what Volker was saying, but just to kind of summarize the idea is that if you have true, and you run this in Python, you get back true. So you can type that in just as it is, because the true with a capital T will be recognized as a Boolean variable in Python. And same thing goes if you type in true and then the keyword and false, then you get the same thing there. You can play around a little bit with it this way just to see how the different tests work. Like if you don't want to worry about putting in some like 1 less than 0 or whatever, you can do it this way. I was just going to kind of, as we go along, summarize what's here so that you guys can see, because this kind of logic, once you've been writing programs for a while, it's like just built in, you automatically see it and understand, but it's something that seems to be a bit tricky when you're first getting used to using these different conditional statements, and especially combining them to know, like, if you want a certain thing to happen when 2 conditions are true, how you write your code can sometimes be a little bit tricky. Yeah. So maybe just to repeat with the simple examples, indeed 2 trues equals to true, and if you would have the or statement, true or true, that's also true. But what if you would have false and false? That would kind of make, in a way, you have 2 similar things on both sides, but if it's 2 times false, that again equals to false. So if you have 0 and 0, that's 0 in a way. And then I guess they will explain
with the or. So if we have or, if we have 2 falses, that's a false, but then at least one true statement is enough to make the whole statement true. Yeah.
Yeah.
That's basically it. Yeah, but then you'll be making kind of, here we have just values, but you can of course use variables, combine, kind of chain these different conditions using the and or keywords. I don't remember if we're doing that actually in this week's exercise, but yeah. False and false is false.
No.
Those are all the cases. Yeah.
I'll put the
Thanks
false
for
word
that.
false.
Yep. Okay, but just test it out with different combinations. So I think that's pretty logical. There's a little note that will come back to, I don't know, maybe in week 5 and 6. So here we use this and or keywords, but there's also another notation for this and comparison or combining operators. So you might use this @ sign in some other situations when we're using pandas and kind of comparing a vector of values. So then you'll have to use a different notation for writing down the and then this kind of, what is it called? Straight line for or.
Vertical
Yeah.
pipe.
Vertical pipe, but we'll come back to this when working with data frames. Okay, so somewhat clear. Thanks, Dave, for clarifying this. So true and true equals to true, true and false equals to false if it's true and false. If it's true or false, then it's true. Anyway, yeah, so enough of that. Maybe, yeah, we still have time, right? Yeah, let's, after me explaining this in a bit confusing way, so let's do one hands-on thing. So there's a code cell where you have weather equals to weather gets the value of rain and wind gets the value of wind. And now we would want to type in a condition that if it's windy, if wind is windy and then weather is rain, we would want to stay at home. I don't know. So if, then we would have the condition, and then we would print stay at home. And then else, if it's not rainy and windy, we would want to print go out and enjoy the weather. Okay, this kind of a scenario. So here we would want a condition where we test that if weather equals to rain and wind equals to windy, then stay at home. In all other weather and wind conditions, go out and enjoy it. Right? So then we would have first weather equals to rain. So let's test that case. You can always run it at this point. So already at this point, only if it's raining is enough to say that, okay, stay at home. But we can add another condition, and wind equals windy, right? Then stay at home. If you want, I don't know, syntax wise, you might use parentheses here, it's not strictly required, but I don't know, sometimes it might make it easier to read that. That's one true or false statement. This is another true or false statement. If both are true, then execute the code block. If at least one of them is false, don't execute that statement, but go to else. Right? And now that we are testing two different things, you could of course then, let's say in the case that we would have rain but no wind, so elif weather equals to rain, then we could tell to print wear a raincoat. So if it's rainy but not windy, then we might be able to go outside, and only if we then wear a raincoat. And then if I would change wind to not windy, I would be told to wear a raincoat. So I can add kind of test for different if everything is true, do this. If only part of my conditions are true, do that. In all other cases, do the else. Okay?
Can I add one thing?
Yeah.
So here the important thing to note, perhaps with the first if test, is that you're going to continue on only if both of those conditions, or well, if either of the conditions are not met. So in this case, because it's an and, if it's not rainy and not windy, then you'll continue on. So like it could be that when you're putting these kind of things together, writing your own code, you have to think through when you combine two tests together that both of those conditions have to be met for the thing to be seen as true, and then if either one of them is not met, in this case, then you continue on down looking for the other tests. And sometimes it can be a little bit confusing if you're testing for one thing, like the order in which you do the tests here starts to become important, because you need to test first that it is rainy and windy to know that you should stay at home, because if you tested first to see if it's rainy, that test would be true, and then you would never check to see if it's windy. So the order in which you do the tests starts to become important when you have multiple conditions, and actually it's often the case that it's important in other scenarios too. If you're checking to see if the temperature is above a certain value, you know, whether you check to see first, well, if you've got a list of temperatures, it starts to make a difference whether you check to see if you're above freezing or below freezing or whatever, because you can eliminate certain other tests from ever being run just based on the order in which you put them into your code. So like if Wolf was switched the elif and the if statements here, you wouldn't get the expected results, even though you've written the test correctly to test for both conditions being true to stay at home. That test would never be met in conditions that it's rainy, even if it's if it is windy. So like if you just flip those two, so that's the if statement first. And then elif second, elif. I think you've got eighth. So the point here is that the weather conditions are clearly rainy and windy, but we still don't pass the test for staying at home because of the order in which the tests are being executed.
Yeah.
So maybe a sort of small thing, but this is a place where like thinking of the logic matters, but also the order in which you do the testing will make a difference.
Yes, a good reminder that always, at least within the code cell in the Jupyter notebook, things are run from top to the bottom, and then depending on your control flow, for loops or if statements, things get executed. But also maybe in terms of the exercises and notebooks, I think it's a good idea to, at the end when you solve the problems, run everything from top to the bottom, so then you make sure that everything is logical in the order in which Python interprets things. Yep. Maybe I'll just flip this back to the kind of correct format, or then not. Okay, so that's most of it about if and elif statements. I have a little extra piece about combining for loops and conditional statements, and I think we have time to go through that as well. Unless there's now some burning questions about Boolean values, if statements, elif statements, else statements. Yeah? Okay. So then how to put this all together. So we learned how to iterate over lists with for loops with Dave earlier in this lesson. And then of course it would be fun to kind of for value in the list. If the value is this, do that. If elif, if the value is something else, do that, and then do something else. So that's kind of a typical flow of writing your code if you're going through some temperatures or cities of the world. So depending on the input value, then we do different things. So here we have a little list with temperatures 0, 12, 17, 28, and 30. And we could create a combination of for loop and conditional statements, which would then go through the list values in the list, and if the value is greater than 25, print that it's hot, and if it's not, then print that it's not hot. So I will show you how to write this, and then you can follow if you want, and we'll discuss how the flow goes in there. So again, for value in temperature, so I'll call that value, or the variable for temperature, so a singular variable name in temperatures. So for a value in the list for temperature in temperatures, and then the indented code block. If temperature is greater than 25, print temperature is hot, right? And then we can have a matching else statement. So in all other cases, if it's 25 or less, print is not hot. So we have the same conditional statement as previously, but we could just kind of push it one level below the for loop. So now we have one level of indentation, and then the if statement requires its own indentation for the code block, then the else indentation, and then after that we would continue in here. If I did everything correctly, we should get kind of a logical output. And again, as Dave showed, we could do a final print statement to understand at which stage we are outside of the loop. Done. Like that. So this type of an approach you'll be practicing in the exercises a lot. Maybe I'll just read this through once. So for temperature in temperatures. In the first iteration, it takes the first value, which is 0 from the list, assigns it to variable temperature, and it continues. If temperature is greater than 0, greater than 25, so if 0 is greater than 25, then print something, but this is false, so then it goes here, then it prints 0 is not hot. Next iteration, temperature gets value 12. It goes here. If 12 is greater than 25, it's not. Print 12 is not hot. Third iteration, 17 is the value of temperature. If 17 is greater than, again, false, print that one is not hot. Fourth iteration, 28 is greater than 25, true, print 28 is hot, and then the same for 30. 30 is greater than 25, print it, skip this, and then as we have iterated all the values in the list. That's the end of the for loop, and then continue here, print done. Okay? Yes? Crystal clear. So that's that for conditional statements and for loops for today, but you will need these skills, I think, every week from now on, so this is kind of a very useful week. Could jump back here to the lesson.
Maybe we can just
check.
I mean, are there any things still on your mind about either the for loops or conditional statements or anything about the logic? I mean, you'll find out, depending on what you want to do with your code, there's all kinds of different combinations of for loops and if conditions and things like that that you'll want to explore using, and well, you'll get good opportunities to do so in the coming weeks. But yeah, are there any remaining questions about any of this stuff? It's, I guess, sort of hard for us to assess sometimes, like for thinking about the logic. Is this something you're familiar with in some sense, like these kind of logical tests and things like that? I guess maybe if you've seen other programming languages, certainly you've seen that, but like, is it also something that's just familiar in terms of like just checking to see if something meets a condition?
I think it's
combining the logical
covered in
tests.
schools, at least in
Yeah.
Finland, but of course that's something to refresh your memory about. Is logical true and true equals to true? I won't go back to that.
Yeah, but no, it's, I mean, it's just, it is challenging in some sense,
Yeah.
because like sometimes just getting a handle of the syntax is one part of it, but then also thinking about the logic for the tests.
Yeah.
It may take a little while, but it gets easier as you go.
Yeah. I think remembering last year's week 3, so one of the difficult things was to pay attention to these less than or equal to. So when you're dealing with threshold values, make sure that you are using the correct comparison operator. So are you including 25 in the comparison? So if 25 is greater than 25, that's not true, but then if 25 is greater than or equal to 25, then that would be true. So simple thing, but that, I think that caused most of the mistakes last year in this week's exercises.
The one other thing that can be trouble is if you're comparing with the equals operator, like to check if the value is exactly equal to 0, for instance. If you have a floating point number, the comparison to make sure it's exactly equal to 0 can be a bit tricky. I don't think we deal with any cases of that, but because the number is often represented by something very close to 0, like 1 times 10 to the minus 16, sometimes you can get into trouble if you check to see if a number is exactly equal to 0. But yeah, I don't recall that being a big issue last year.
Okay, so we're quite good in schedule. We'll discuss a bit about good coding practices, so our kind of reoccurring theme, and then we'll introduce exercise 3 that's out there. So in the okay, I was also checking. Well, related to that, we have already discussed these good coding practices in weeks 1 and 2. In the first week, we discussed variable naming, so pothole case, camel case, these sorts of things, and not to have too long variable names, but also not like super cryptical ones. And then also we discussed about describing your code using comments or then the markdown in the Jupyter notebooks. Today's topic is writing readable code, and of course good variable names and good comments are part of writing readable code, but here the focus is on the actual Python code. So how can we make our code more readable to ourselves and to others and more consistent with the kind of generally agreed conventions in writing Python. So we'll go through some highlights. Please, Dave, stop me if I'm talking something stupid, because I have to admit that my code is often not the most beautiful one to read, at least when I'm returning back to it after 6 months, but then following these guidelines helps us to make the code easier to understand. And the whole point here is that often you are able to write a block of code that works. It produces the correct output. -3 is less than 0. Great. But then the actual code might be a bit messy, or you might have kind of ugly variable names, or if I give my code to Dave and he's like, wow, what is that? Okay, let's see, let's run. Okay, it produces the right output, but then the point of Python is to be machine readable, so the Python interpreter reads it and executes it. The syntax needs to be right, so you have to have the indentation with for loops and conditional statements for it to run, but also the whole point of Python is to have this beautiful readable kind of language that is also, the layout is such that it's easy to look at and it's easy to follow the flow of the code only by reading and looking at it. And indeed you can read this little cartoon when you have the time, but the point is that then there are these some general agreed upon guidelines for writing readable Python code.
Yeah, I mean, one of the things that is somewhat unique about Python in general is the fact that it does force you to indent things that are part of a loop or part of a conditional statement. And a lot of other programming languages don't enforce that. So if you don't indent something that's part of a conditional statement, especially if you have, 20 or 30 lines of code in there, it can be difficult then to tell like what is part of this test and what is not. And Python, the reason that we kind of highlight these readability guidelines is the fact that they exist, and that the Python group from the beginning was really thinking that we want to make sure that the code is readable. We want to address some of these problems that exist in other programming languages. So it's something I think that is pretty essential part of programming in Python.
Mm-hmm. Yeah, and especially when then eventually sharing your code with others, it helps them to read it, and also if you would then, for example, combine, you produce some method for some bigger project, then your code would be compatible to the style of others. So that's also the one point. So luckily there are these guidelines for writing beautiful code in addition to the actual syntax that makes the code work. So we have this PEP 8, I think it's Python, what was it short for? Yeah, I checked it yesterday but forgot, we can check it later. But it's Python enhancement protocols or something like this. Yeah, which are kind of generally agreed upon conventions for layouting your code, for commenting your code, for naming your variables. So let's have a look at that. So it's a document on the web, style guide for Python code, and it has kind of an extensive list of contents. So we won't be covering everything today, but just to introduce this to you, that this is a place to go to if you're thinking about formatting your code. So you can have a look at the original version, but for your convenience, we have kind of picked a few highlights that you can already now start using while writing your code with the skills that we have now. Already next week we'll introduce functions, and then there's a set of formatting and documentation guidelines when it comes to functions, and we'll discuss those next week. But here we could briefly mention a few of these PEP styling guides related to line lengths, indentation, white spaces, and then kind of how to write one thing per line. So I'll go these through quickly, right? So one point in Python that is that you should limit, if you have one line of code, it shouldn't exceed 79 characters. I think in these Jupyter notebooks you can kind of go as far as you want. But in text editors, you often have this kind of, it will give you some red light if you are writing too long lines. And then of course, that means that sometimes you need to break things into multiple lines. And with lists already, we have learned that with using brackets, Python kind of interprets implicitly that if you have brackets and there's a line break in the middle, that's kind of one statement or one line of code in a way, how Python interprets that. Yeah,
so part of this is based on sort of historical practices that in some programming languages before, the code would simply not be executed if it was past the 72nd character, which goes way back to like punch card days. But even still, like if you write Fortran code, for example, if you go past the 72nd character for certain types of Fortran code, even modern Fortran will sometimes not actually execute the code. Python will always execute the code no matter how long the line is. There's probably some obnoxiously long line limit somewhere, but for the most part, I've never had a case where like the line's been too long to actually run the code. It's more just about the style and readability.
Yeah, and you could have this backlash. I think we have it in one of the first exercises. It's not actually encouraged unless in some specific cases with specific statements that we're not maybe covering here. So with brackets, with lists, you can just have a new line character, and that's it. And it also makes the code more readable. That's the whole point in here. Okay, then indentation, of course. With if statements, for example, here, it's part of the syntax. You need to indent the code in order for it to work. But also there's other cases where you can use indentation to increase the readability of the code. This is kind of a simple example, but if you would imagine that you would have like a super long conditional statement, in there you might want to break it into multiple lines. And then there's, depending on which statement you're using, then there are certain rules how you can or cannot indent the code, or should not indent the code. So for example, with if statements, you could break the condition into multiple lines, then you'll just need these brackets. So you'll have, again, this kind of implicit line continuation. And then to increase the readability, you could indent it again. In my opinion, the first option is here actually quite okay, but just to notice that you can use indentations in different ways to increase code readability. And one of the approaches discussed in the guideline is this kind of using hanging indentations that we might use next week. So you could also write the list in this way, that you have the starting bracket, then no values on the first line, then all the lines, and then kind of the closing bracket aligned upwards with the rest of the content. So that's kind of in compliance with the style guide. So there's not maybe one right or wrong answer how you should format lists, but this is also one way you can do it if you want to make it neat and readable. Okay. Then white spaces and binary operations. This is maybe something that we will give you comments about in your exercises if you're not complying with this guideline. So always, if you're assigning a value, or doing these comparisons, so you should always surround the operator with a single space. That's just to kind of give a bit of air to the code and make it not like super squeezed in, so you can actually read the variables. There are some specific cases with these kind of operators, so if you want to highlight one over the other, so you might use a case like this. But in principle, always have one space around these binary operators to make your code kind of consistent and easy to read. Yep. And then this is also something we see often in the exercises, just to note that whatever function you are calling, Python will work even if you have a space between the parentheses and then the function name, but don't have it. Always have the kind of parentheses right next to the function name. And then Python would allow you to run multiple things on the same line, kind of use these compound statements. PEP 8 generally discourages the use of such approaches, so you could write if statement on the one line, but rather have it nicely indented there. There are a few special cases where you can squeeze in multiple things on one line. So those of you who want can check the advanced note here at the bottom. I won't show it here not to confuse everybody, but there are ways in which you can, for example, do a for loop and an if statement in a one-liner. And it might be a good idea, but then if it gets like, if you have 80 characters long one-liner, then it's maybe not a good idea. So we always balance between code length, code readability, code efficiency when writing Python code. Okay. All right. So that's it about writing readable code. So from now on, when doing the exercises, try to make them work, of course, but also try to pay attention to the readability of your code, comments, variable names, and such. So we then still have 5 minutes for introducing the exercise. Again, deadline is next week before the lesson. We have practical sessions tomorrow and Friday if you need help. And you should be able to click on this GitHub Classroom link. Let's see. I'll just do it for Dave. There we go. So yeah, I can introduce it quickly. Quickly here, so this week we start to have a bit more actual programming to do in the exercises, but it should be interesting. This week's exercise has 3 problems and then a 4th optional problem for you if you want to kind of test yourself and do a little fun flag exercise. But the problems 1, 2, 3 are kind of compulsory or make up your points. And each of these problems has their own notebook. And again, you will of course start by cloning the exercise on your computer and then start working on the exercise, and remember to add and commit your changes while you are working to save your work. Of course, now I'm not loading these. Okay, there we go. So there's, in problem 1, there's this little snippet for those of you mainly who are working on your own computers. So you can just run it. If you don't get any errors, it's fine. So we are using this semi-automated grading system to give you the points, and there's some things running at the background that you have to have set up, but otherwise you can ignore that one. In the first problem, the idea is kind of to mimic this kind of batch processing of data files. So especially when working, let's say, with GIS data layers, you have like maybe a folder of file names, and you do repeat some process for each file name. So you hear that there might be some kind of a for loop involved in here. So in principle, what you need to do is to create create a list of file names. Kind of, we could imagine that this would then facilitate our batch processing workflow. So you should have some kind of for loop structure, iterate over numbers, and then end up with something like this, that you would have a list of file names with kind of this increasing number in there. So you'll need to combine for loops, range functions, and then something you learned about with lists last week. Maybe that's enough of
maybe
that.
One thing to note here is that, I mean, as you guys saw last week, there'll be the cell that has like your code here that you should be making the changes in. You'll be able to edit that cell, and then underneath it there'll be usually a few tests. Some of these tests are going to be things that are visible that just check to see whether you've got the right answer, like printing the file names. You can just yourself check to see, does that list of file names look like the thing above? But then there's also things like this assert equal test there. These cells, I think, all should be read only, so you won't be able to edit them, but you should be able to run them to see whether or not your code actually produces the results that it should. And I think in this week's exercises, there are a few more of these tests that are visible for the different problems. So it's your way to kind of check and see whether you've gotten the right solution. It's just by running those test cells that are underneath the place where you've made the coding change. And you can see, especially like the very last one here, that it says this cell checks the content of the list is okay. You do not need to modify this cell. This is actually something that runs only for the instructors, so you can't, like, if you run the cell yourself, it doesn't do anything, but it allows us to do a couple extra tests when grading the exercises on our side. So when you see these things, you can just run the cells. If you can't edit them, rest assured that's the way it's supposed to work. Those are read-only cells that just allow us to do the test to see if the code you put in does what it's supposed to do.
Yeah, so just start by erasing the error, and then make sure you have your solution above the test cells. That's all you need to worry about. Okay, 2 more problems. Problem number 2. Let's hope it renders. Okay, so classifying sounds like a conditional statement. So you'll need to classify temperatures into lists. So here we start by having empty lists, and then you do some maybe iterations, conditional statements, and populate those lists with correct values. That's basically the point of problem 2. And we provide the list of temperatures readily here. Again, you can erase the errors. And then finally, maybe also there might be these kind of only markdown written answers, so please also fill in those. And then problem number 3, it's a bit similar idea as with problem 2, but here we're working with coordinates, so finally something that is geographical. So we have the coordinates of all the weather stations in weather observation stations.
It's the ones that are more than 70 years old.
Yeah, old weather stations, yeah. Across Finland, so we have point data across Finland, and our task would be to kind of allocate these to northwest, northeast, southeast, southwest blocks. So again, we provide you the lists here. So the idea is here that always for example, here at index 0, the first item in the list here has its latitude on the same position in the latitude list and same position in the longitude list. So kind of similar approach that Dave showed in the for loops lesson. And then we again start by creating empty lists for the outputs, and then we iterate, use conditional statements to put the stations in the correct lists according to the values in the different lists. So that's already quite a lot to do, but hopefully this is kind of a fun exercise. Finally, if you haven't...
Can I say one thing about that?
Yeah, sorry.
Just go back for a second.
Sure.
There is a small typo in part 4 here. In the comments that we can see, in the second cell here, the second test cell, it says hint, there should be 2 stations in this class, there should actually be 3. I've already put a comment in Slack about this. And in the last one here, it says hint, there should be 12 stations in this class, there should actually be 11, not
Okay.
12 there. So we fixed the test, so when you run the test for your code, it should work properly if you've divided things into the right groups. But we need to fix the comment, we'll do that, but if you've already made a copy of the exercise,
Yeah.
like if you've already accepted the assignment in
Yeah.
GitHub Classroom, then you'll note that there is a small typo here in the comments.
Okay. Yeah. So indeed, if you haven't cloned the repository yet, we'll be fixing this
Yeah, and
typo
I'm
in
not
half an
certain
hour.
whether you can update it or not. I don't, in the past you couldn't, but they may have changed things so you can update the assignments now, I'm not sure.
Yep. Okay, and then finally, there's a nice little puzzle about plotting the kind of American flag, I don't know, using nested for loops. So that's optional, but a fun task. So you can do it if you want. All right, so that's it for week 3 for loops and conditional statements. If you have any questions, we'll be here and see you in the exercises and next week's lesson. Yeah, thanks. Yep, yeah.